I'm back, guys. This is a video I'm doing just on capacitors, and I'm not going to get in depth with them, but I had a viewer send me a message asking me about capacitors a little bit. He had seen one video that I'd done talking about putting in safety caps, and he wanted to know why and the reasons for that, and then just talking about caps in general, the various different caps and stuff. So I thought we would kind of just do kind of a in a nutshell type thing, not really get too deep into any particular theories. If you want more information though, one site that you can go to, I mean there's various sites, you can just start Googling on on the internet and look up things about capacitors and learn more about them. But justradios.com is a great place for especially beginners to kind of get a stock of parts and get started, because they sell grab bags of, they got capacitor kits, resistor kits, all kinds of different capacitor kits in their capacitor kits, and also in the resistor kits you can get any kind of different type of resistor, including 1 watt and 2 watts resistors, as well as kits for capacitors in various different caps, including Micas as a kit. So I mean, you can get yourself stockpiled up. Are they best caps? Well, they're decent caps. They'll work just fine. Probably the only thing I have used them. The one thing that about their electrolytics, mostly what they sell is 85 degrees C caps for temperature rating, which is fine. They just won't last as long as 105 degrees C. But nothing in a radio is ever going to even get anywhere close to that temperature of even 85. But the point is that's the only thing they do sell. If you want something in 105 at a decent price, Mauser Electronics, Mauser.com is a great source. They are real reasonable on name brand like Nishikans and a few others, and they're 105 degree rated. So plus they also sell some really nice like skinny electrolytics and stuff that are high value in the microfarads, but much smaller around, so that you can fit, if you do stuff cans, you can fit them in the cans easier. But anyway, that's something totally different. But on justradios.com there is a place there that talks about capacitors for radios, and they kind of go through all the generalized stuff. It's not in depth, and it's a great read for anybody who's wanting to learn. Okay, these guys here, right here, and probably just easier for me just to keep them centered here and zoom in on them. Are safety caps, just a few. These two here are what is known as X2 caps, safety caps, which means if it's got an X, it means across the line. And what that means is across your power line that comes into the radio, it's across from the hot to the neutral. Whereas Y is from the line to ground. So, and now the little blue one here is the one that I've been starting to buy a lot more because it's universal. It's X1, Y1. It can go across the line, or it can go from line to ground. Only reason I do that now more than anything is eyesight. A lot of them you buy will be pretty much in this size category, and without a little magnifying glass or something, it's kind of hard to even read for me anymore, to read the little X2 that's on there. It's printed real small. The printing on this is extremely small too, so I make sure I keep them in a special drawer where safety caps are, because they could look like a ceramic cap, and that's basically what they are. They're a special ceramic cap with the epoxy coating on them that is a special coating. Now, the two reasons why you use these as line filters. Now, why do you need line filters? First of all, why do radio manufacturers put them in and have these which they put paper caps in, so they didn't put safety caps in. They hadn't even made them at that time or had been invented. The reason for line caps is your power wire, the line cord that you plug into the wall, and plus all the power lines in your house, and they're connected out to the lines going on the poles. That's all big, one gigantic large antenna. So it's picking up RF energy, noise and interference and everything from all over the place. Gets transmitted down through those wires, down through that line cord, in through your power supply. None of your filtering circuits in the power supply or throughout the radio really is capable of dealing with that noise, that RF energy. So it's going to get right on through, and it's going to go right through the IF and right out to your speaker and right to your ears as being noise. That's why these things are used, is to filter out that RF energy. They're sized out so that they take it to ground and get rid of it. Now, the important thing is, radios that generally had these had a 2-wire cord on them, so the chassis had to be grounded some way. And most of the radios, a lot of those radios had external antenna and ground connections. So you hooked ground, to earth. Now, there was a question asked of me also in the comments, does that mean grounding? Can I hook to the third prong or the grounding prong on an outlet? And yeah, you can. If your house wiring is wired correctly, that third prong, the lower half moon shape, half round shaped plug, is ground. It's a grounding conductor. It is connected to a piece of copper wire that goes back to your breaker box and hooks in there on a special terminal strip that at one end of that terminal strip is hooked to another much heavier ground copper wire that goes to an 8-foot ground rod that is stuck in the ground. So yeah, you can ground off of that if your house is truly wired correctly. And I that's a big if, because I've seen houses where they went in and switched the plugs out and just put 3-prong plugs in, and they didn't even have the wiring for them. But you can check it. If it's hooked up, it'll take just your voltmeter and go between line and that prong, and you should read 120 volts here in the US. So, or roughly thereabouts. Now, why use safety caps? Okay, 2 reasons. One, these are flame proof. Unlike the paper tube caps that generally a lot of the radios have, which are these guys have a bad tendency. They'll just explode it right out the end and shoot sparks and flame right out the end when they give out. The whole darn thing can catch fire even. These will not. So that's number one. So number one safety feature is that they just will not catch fire. They've been well tested. These things are tested way above their AC voltages that they're covering. This one's like 275 volts. A lot of them's in that range, and they're tested like 2,000 or 2,500 volts for a minute across them. So they're real durable, and they will not blow up or explode or cause sparks to fly, flame to fly, catch fire, and anything. The second reason is they're self-healing. And basically what happens is if they do develop some sort of potential short between the plates, in there, it'll arc through. They're designed to arc, but when it arcs, it burns back the plate far enough it won't arc anymore. And then it creates enough heat that the dielectric actually melts across and closes the hole. And generally, it's so minute, even if they've done this a few times, it's so minute it won't even change the capacitance. It's so small, but they are self-healing. So the two reasons why they're used is the primary safety is so they don't explode, short, or catch fire, blow sparks, do anything nasty like that. And the second thing is that they are self-healing. So that's safety caps. And the two basic varieties, and they come in various different sizes. But as far as microfarads, but the big two varieties is, well, I should say three varieties, is the universal, which is generally in this casing like this, which is either for across the line or from one side of the line to ground. Anything that's got an X in it means across the line, so X cross line. Y just from line to ground, which will be the only other one. Now that's safety caps. Some other type of caps you run into in radios look like these guys. Now focus, please. Thank you. It's nice how we all talk to our cameras like they can listen. These are micas, molded micas. Now there are some paper caps made this way. Mica Mold made them. Generally those are usually actually a little bit longer case. They're kind of like an elongated case like this, but in this size form. And a lot of times they'll have instead of coming to square tips, they'll actually cut off right here and here and here, kind of angle off a little bit. But they also, well, it'd be just straight marked out with no color code, or as a general rule. Mica Mold did produce some that went with a dot system that they use, but to be honest with you, I've only seen two. Most of the time you don't see them too much. But anyway, these are micas. Be more accurate, they're silver micas, which means they have silver plates. Mica is a rock, it's a mineral, and it has an extreme strong dielectric strength. Generally these are usually like 500 volts or higher. There are some lower voltage ones, but most of the time they're running in that range of 500 volts or higher. You will find most of them in the picofarad range. At the most 1,000 picofarads or 1 nanofarad as a rule, but there are some larger ones. You can get much bigger, especially today you can get much bigger ones. But back in the day, generally these were used. They were smaller capacitance, and not really so much. They did make them. They did make clear up to tens of nanofarads, but they generally used them in the front end of the radio, the micas, and where they needed something more in the, for the frequencies, more in the picofarad range, or just maybe a nanofarad or two. That's your older type. Your modern type will come in a package similar to this, something like this. They come in various different sizes. This is 2200 picofarad, 5%, and I believe it's probably a 500 volt, maybe 1,000 volt. It's not marked. Now, there's also micas that were put in IF cans that were open. They had no casing whatsoever. They generally will cause problems. These also can fail. Same reasons as the plastic molded paper caps. Around these leads, they start leaking air into and moisture, and that starts corrosion of or tarnishment of the silver, and which then in turn causes all kinds of headaches inside the cap, which will cause them to become leaky and lose their capacitance, and consequently they don't work anymore. Now, micas are generally used where they're not extremely temperature dependent, and they're really good, well, they're good with high frequencies, but they work fine for lower frequencies too. But where something is kind of critical as far as temperature, in other words, if there's a change in temperature or voltage changes, they are pretty stable on both cases. So a lot of manufacturers use them in the front end of a radio, like in the local oscillator and RF sections and stuff, and mainly just because of that reason. That way any fluctuations in temperatures or any fluctuations in voltages would not directly affect the capacitances, and they'd stay stable. You can use any cap anywhere on a radio, but there are limitations. Paper caps are not extraordinarily temperature dependent, but they are very voltage dependent. So voltages can, especially when they're in low values, like in the picofarad, and they do make picofarad, they did make them in paper caps. But in that range, and high frequencies, paper caps, my goodness, minute changes in temperature could really change their capacitance tremendously. Ceramic caps, on the other hand, was more voltage dependent. Well, not so much more than paper caps, but I'd just say more temperature dependent and then voltage. But voltage affected them to a certain extent, and temperature could be really bad on them depending on what style cap there was. Now, I will be showing you one style that neither one had any effect on. They would work just as good as any mica cap at any time. But this is what you'll see generally is the mica caps, unless they're open. Now, there are mica caps that are not silvered. The top of that's mounted in IF cans in the 30s, and a lot of the patters use mica sheets, but they use just either tin-plated copper or tin-plated steel plates. These didn't generally get too badly corroded. It took a lot more to corrode them or rust them, and as long as they weren't like really dirty or anything, they were fine. You didn't have any troubles with them. But they used mica sheets in between them, mainly because mica is got a real strong dielectric strength for very, 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 very thin sheeting. And like on the IFs, the primary side, you've got full B plus going across that coil and across that cap. Ceramic caps come in a variety. Most of the time you see them like this, little disc caps, bigger disc caps. These guys are really temperature dependent and somewhat voltage dependent. Not as bad as the paper cap as far as voltage, but definitely bad. But the temperature really kills them, because the ceramic really has a pretty decent coefficient of expansion with temperature. So what happens is the ceramic is, and that's what they are, just a piece of ceramic with two plates on each side, and the ceramic can expand with temperature, and it's got a pretty decent coefficient of expansion, so it actually reduces the capacity. It tends to be more a problem with high frequency, because high frequency capacitance is real touchy. All of your components values are touchy. But if you use them, and a lot of manufacturers started using these in low frequency areas and DC areas, and as blocking caps and things like this, and low frequency signals and stuff, so they were fine. Today, this is what you'll buy in a ceramic, and like I say, they'll come in various different sizes and different voltages and different values. They can handle extreme high voltage. You can get these things 6,000 volts, 10,000 volts, and on up. Another style, though, well, there's a third. Let's look at the second style first. This is a tubular, but it's a solid tube, ceramic. It's like these here, but these are hollow. Well, the paint's in there, but they are hollow tubes. This one you can see through. These guys are extremely stable, both temperature and voltage. Just as stable as any mica, if not some arguably more stable. You'll find a lot of these used in test equipment, more than any other type of cap, especially signal generators and stuff, because of their stability. Not to be confused with dog bone resistors. Because like I say, there are some tubular ones that are solid. They're a little bit more problem child with temperature. But the big difference between the ceramics and the dog bone resistor, besides color coding, if I get them in here, is the fact, if you look at the dog bone on each end, here and here, where the wire is fastened on is pretty equal and even. On most dog bones, it won't be a whole lot of variance, and they're pulled back from both ends a little bit. But on this end, on the ceramics, one end is always at the very end, or dang near at the very end. The other end will be pulled in. They did that for a reason. It isn't to adjust the capacitance, but they did it for a reason, so that they would not ever be confused at a glance with this, with one of these resistors. So, but these, they're just ceramics. And generally the tubular ones, and even some of these are in a little bit lower frequency. These are used in the front end of radios sometimes, and as well as an IF can sometimes, as well as, and you'll see them in different colors. These are brown, there's some white ones, and various different styles. You'll find them in a lot of test equipment. Uses them, at least like signal generators and the like. All right. You got electrolytic caps. You got axial and radio. They are in two different varieties, flavors, basically. You got polarized, which is these are, and the way you can tell polarized, excuse me, the way you can tell polarized is the fact that it has a negative marking on it. This one here points an arrow to this end. The radio ones, generally the can is ground or negative, but this is a polarized radio lead, and you can see on this side, which I've got these bent to keep them from rolling around, but it's on the short lead. It says negative. Standard convention is the positive lead is the longest, negative lead shortest. But on radio leads, the vast majority of them, this can is floating. It's not connected to the negative. So, whereas on the radio or the axial, they could be. Now there's another style of electrolytic that's non-polarized or unipolar. So they won't have a marking on them that shows we're negative, because it doesn't matter. Those are used in certain special circuits and some places, and some equipment, as well as motor start capacitors used in electric motors. They come in variety of sizes and variety of voltages. and the like, just like a lot of capacitors do. Now, the old days, you had paper, or last the caps we're going to look at. They can be in a plastic encasement, like this one with a little paper tag on it, or they can be in a cardboard tube with wax closing off the ends. These things get moisture in them, causes all kinds of problems, so they go bad. The modern day convention is the film cap, and there's just basically it's plastic film instead of paper between the plates. Propylene, I believe, and polyester, and various different ones. There's some that are metallized, and there's various different ones that are used to make up these. These are generic, like you get from Just Radios, JB brand. I've got some others that I've gotten from Mauser and stuff. Now these here will be in this style, like this, which is the ones I like buying, is these axial ones. They're 630 volt caps. So for the most part, most of the time, any of these caps you replace in a radio, generally these will directly replace. You don't have to worry about voltage, because most of them are 200 or 400 or maybe 600 volts. Although, as you notice on this one, it says 1600 working volts DC. In some radios, there are high voltage cap across the generally across the primary, the audio transformer, output transformer. In some spots in TVs there'll be high voltage caps too. There were paper caps, but you can buy high voltage of these guys too that are higher. You can buy 1000 volt, 1500 volt and stuff. And give you one example here is this ASC. It's basically designed the same way as this, except the dielectric is much stronger and can withstand above 6,000 volts. They're rated at 6,000 volts. I guarantee the dielectric can withstand more than that. But you can buy, and you can buy them higher than that. You can go up 10,000 volts or higher. Well, that's about does it on the caps. Like I say, I'm not going to get too deep into theory and stuff. It's not really the scope of this. It's just basically the basic general. There's other type of capacitors out there and other things, but for most radios and TVs, this is what you're going to find. And so I hope that answers the question about why use these safety caps, and kind of give a general idea. Again, justradios.com. You can go to that site, and they've got a little more information and some stuff on there. So, plus, like I said, again, it's especially for newbies. It's a great place to get started, getting parts and stuff, and later, you can start sourcing out to other sources if you want. But you can get started pretty good there, since they do have the what they call kits, but grab bags of caps of all varieties: safety caps, micas, ceramics, film caps. There's other styles of film caps called orange drops and stuff, and so they've got those also, and polystyrene caps and so on. So anyway, I hope that answered any questions, and so I think this is long enough, and on the next video I'll be showing you what I've gotten done on the RCA. So until next time, thanks for watching. I'll see you guys on the next video.